Hello friends, in this video, in this session, we will complete all the remaining practical examples related to connection framework. Okay, so first is tree map demo. We will see them one by one. Tree map demo. Package tree map demo is created. Okay, so in this video, we will cover complete remaining examples. Okay, so tree map is created over here. Key value pen string is double over here. Same example. John Doe, Tom Smith, person name and his account balance. And to get the set view using entry set method in the set object, and for each type for loop, we are iterating through the set and getting the key and value and display them. Okay, so we will run this project. Okay, so what is the difference between the previous example that we have seen, hash map demo, and this one is putting the sorting of elements. Okay, so all the elements are sorted. Jane Baker, first of all, J will come alphabetically, then R will come, then T will come. Okay, and John Doe's new balance is displayed over here. Okay, you can go through this project. Java.util.map is imported over here. Set is also imported, and tree map is also imported. If you do not remember this, you can directly import java.util.start. Okay, at compile time, this does not make a difference. It does not make any difference when you are importing complete package, but at runtime it adds the time complexity. More time it takes for the processing of project. So better way, the only packages that you need, only classes that you need, you will import instead of completely importing the package using package name.start as far as possible, like we have seen in packages and interfaces chapter. Okay, so go through this project. Same example is over here, only the difference is instead of hash map we are using tree map. So I will close this project now. Next is compare demo. For comparator, we have created this package comparator demo. So this class implements the comparator of type string, comparing string A with string B. Okay, A string and B string are initialized with A and B respectively, and B string dot compare to A string. So in the reverse order, comparison will be reversed. And reverse method neither it is required override and nor it is common, as we have seen in theory part. Now again preset is created. Preset of type string and a new comparator object is passed over here. So what it will do, it will add the elements to this and it will compare and sort them in reverse order. Okay, for each string element in TS, it will take out the element and print it like element plus space. Okay, and since comparator object is passed over here, it will initialize the comparator new my compare. This class will be initialized when you are creating the object, and then its compare method is called because it implements the comparator. So this class itself is a comparator now, and it compares string in reverse way. B string compared to A string. Okay, you can go through this project. Okay. So now I will close this one and I will open the next one. I will close this project. Then next project is tree map demo 2. Package tree map demo 2 is created. Okay, in this class, it compares last whole words into string. So it implements the comparator of string like in the previous example. 2 strings are created, 3 variables are created, I, J, and K. 2 strings are initialized with A and B respectively. Okay, so last two strings like you are having first name and last name. So after space within your full name, whatever will be your last name. So it will first find out the index of the last name. Then K is equal to a string dot substring of I compared to B string or substring of J. Okay. So string A and string B is given over here, and substring starting from I, that is last name, A's last name compared to B's last name. Okay, if K is equal to 0 means they both match. So it will compare with the A string compared to B string with the entire name. Last name match means taking entire name, otherwise written K. Okay, so K will be your index and K will tell that the sequence, okay, which will be your first last name, then second last name, and so on. Equals is not needed to override. Then tree map is created. Key value pair is string double like in the previous example, person name attribute or balance. Then set view is obtained using TM, that is tree map dot entry set. It is saved in set. Then for each map entry, string double map entry colon set get key and get value. Okay, and deposit 1000 in John Doe's account. First of all, John Doe will be get using the tree map dot get entry key, and its value is updated key and updated value balance plus 1000 currency, and new balance is displayed. Okay, so what it will do now, it will compare the last names of the full name. Okay, so okay, so Jane Baker, B will comes first. B comes first in alphabetical order, then Do, then Hall, then Smith, and then again Smith. So between Ralph Smith and Tom Smith, alphabetically R comes first and then T. So R and T are displayed like this. Okay. So then go through this project. It's somewhat tricky, but if you understand it, it is very easy. This will find out the index of last index of string A and string B, that is two names, and if both are equal, it will compare with the complete name or first name. Okay, so these two things you have to understand. If you understand these two things, this program is very similar or very simple, very similar to the previous example. Okay, nothing different in this. Again, set view is find out, and then again for each and for loop is called for iterating the tree map, and get key, get value, we get and display the values. Okay. Okay. So now we will move to the next project. The next project is algorithms demo. Project name is algorithms demo. Package name is package algorithms demo. Class name is algorithms demo.java. Here creating and initialize linked list is done. Then minus 820 minus 28 are added to the linked list. Then reverse order comparator. Okay, so depending upon how you provide the criteria for comparing, depending upon that, it will be compared. So collections dot reverse order. This is algorithm for reversing the elements or entries in the collection linked list. So this reverse order object is created comparator and this is given in the R, and this R will be comparator of type integer. Okay, so sort this list using comparator collections dot sort linked list using this comparator, and what this comparator tells the compiler that is collection dot reverse order. Okay, so whatever entries are there, those will be compared in reverse order. So now we will sort list in reverse order. For each integer I in linked list, it will print I plus space and its new line, and shuffle, that is randomize the list, display randomized list using for is type for loop, and again new line. Then again minimum and maximum of the collection is printed using of the linked list. Okay, so now we run this one. List sorted in reverse order, then list shuffled, that is randomized, minimum in the linked list, minimum value of the linked list and maximum value of the linked list. Okay, this value is independent of the shuffled one. Okay, even if your list is shuffled or randomized, it is all the elements are swapped randomly, still your minimum and maximum value will be the same as the original linked list. Okay, so now you can go through this again, understand this. You have to import this java.util.collection, then java.util.comparator, java.util.linked list. Okay, then this is the linked list element addition, then create a comparator, then sort the collection and display the list. Again shuffle the list, again display the list here, and minimum and maximum are displayed. Okay, so now we will move to the next one, arrays demo. I will close this project and I will move to the arrays demo. Package arrays demo is created, then arrays demo.java class is created. Arrays is important thing you have to input over here, then allocate and initialize the array. Okay, array of type size 10 is created, and array is initialized with 0, -3, -6, -9 and so on. Then display sort and display the array. Original contents are displayed, then sort, and then sorted array is again displayed. Okay, fill and display the array. So what is the fill method? It will fill with the given values. For this particular array from index 2 to index 6, the value will be filled. All values will be filled like -1. After fill, display the array. Again sort it, again sorting, again displaying the array. So now binary search is called value at value -9 is at location, integer index arrays dot binary search array and -9. So binary search will find out the value index of the -9 and fill the index. And this display method is written separately, so it will display each and every element of the array each time the display is called. Okay, so now we will run this one. Original contents 0, -3, -6, -9. Then sorted one, the actual order, because minimum value comes first. My great larger minus value will come as the minimum value, and greater minus value will be the greater value. Okay, sorry, the minimum minus value will be the greater value. Okay, this is the actual order. After filling, -1 is filled over here. After again sorting, -1 comes here. and index of -9 is at location 0, 1, and 2. Okay, so this is the project. So close this one. Move to the next one. Old style. Package old style is created. Okay. These lines will store strings, but any type of object can be stored. Old style will not restrict the type of object. Here array is created. Okay, and no type is specified using this angle bracket. Okay, this is the old style. Packages imported are with array list and iterator. Okay, so added 1, 2, 3, 4. You can still add any integer value, any float value, any kind of value. But while taking out from the collection, what you have to do is you have to cast it to the particular type in the old style code. Iterator, while iterator has next, it will take the element and it will cast to the proper type, because you are adding only object, you are not adding only type of string. The explicit cast is needed over here. And string is string dot length characters dot. Okay, so here you can add any type of value, so it is not a type set like a generic code. Okay, so now go through this very simple example. Okay, so we will run this one. One is 3 characters long, 2 is 3 characters long, then 5 and 4 characters long. Okay, so now we will move to the next one, that is the new style code. New style. What is added in new style? Only particular type of values are added. Okay, so array list of type string. So it is restricted to only add the string objects. Here also array list and iterator are added. 1, 2, 3, 4 are added. Iterator object is created to iterate through this list. Okay, while iterator has next string str is equal to iterator dot next, no cast needed because it is only restricting to add the elements as string. Okay, so now this line will also give you the error if you try to create a iterator for type integer, because the restricted type is string over here. This will give you error. Again, this will also give you error. Iterate dot next give you integer I. It will not give you integer I, only string, because type is restricted to what? Type is restricted to what? String. And string is string dot length characters long. Okay. So same output is there. 1 is 3 characters long, 2 is 3 characters long, 3 is 5 characters long, 4 is 4 characters long. You can go through this. The only difference between old style and new style is type restriction. But that only difference make a big difference because it adds type safety in the code. Okay. Now, move to the next one. Next one. vector demo. So package vector demo is created. In vector demo, new vector is created of type integer. Okay. Initial size, initial capacity is displayed. Then adding element 1, 2, 3, 4, capacity after 4 additions. Then add element 5. Current capacity is V dot capacity. Okay. Then add element 6 and 7. Then current capacity is V dot capacity. Then add element 9 dot 9 and 10. Then capacity is V dot capacity. 11, 12 is added again. Then first and last element of vector is displayed. Okay, if vector contains 3, it will display vector contains the 3. Then enumeration is used to have the elements in the vector. Iterate through it. While vnum has more elements, it will take out and display the next element like iterator. Okay. So now capacity, initial size 0, initial capacity 3. Okay. Capacity after 4 additions is 5. Current capacity 5. Current capacity is 7, 9 because new elements are added. First element is 1, last element is 12. Vector contains 3, it is 2. Okay, and elements are vector are displayed using the enumeration interface. Okay, so enumeration methods has more elements. It will display next element plus space. Okay, go through this one. It is very simple example. Okay. Okay, so move to the next one. Vector demo is closing. Then next is stack demo. Package stack demo is created. Stack demo.java is created. Okay, so for show push, exam show push method. Stack.push. Stack of integer is passed over here and element is pushed using integer a. Okay, so pushing a and stack is displayed. Then show popping plus removing and displaying. Okay, st.pop, then display and then again display the stack. Okay, so first of all stack is empty. We'll show you st, then 42, 66, 99 are pushed and then pop is called 3 times and for last time it will display the empty stack because there are only 3 elements present, 42, 66, 99. While popping 99 will come first, 66 will second, 42 as last. Java util empty stack exception is available in java.util package and java.util.stack you have to import it. Okay, run this project. Okay, first of all stack is empty. Pushing 42, now stack is having 42. Pushing 66, now stack is 42, 66. Pushing 99, stack is 42, 66, 99. Then popping 99, 42, 66 available. Popping 66 till since popping remove the element from the top of the stack is becoming empty now one by one. Then stack is again 42, popping 42, stack is empty and it is displaying the empty stack. This is the same example we have seen in theory, so no need to explain and it is not a hard one. Okay, stack class is also already created. You just have to use the methods push and pop. Okay, so only modification what you have done is in the show push method we will display the pushed item and stack elements. Otherwise st.push and st.pop is sufficient. This is for our convenience. We have added these 2 lines and for adding these 2 lines we have created these two methods, show push and show pop. Those are not compulsory. Okay. Okay. So now next project is hash table demo. Hash table. HT demo. Key value pair is string double. New hash table string double. Then enumeration names string double balance are three variables created. Same examples are there. Show all balances in hash table. So balance dot key will get in names. While names has more elements. So what is names? Names is the enumeration, not a iterator. Okay, enumeration of type string is created, and balance dot keys will get the keys. Okay, while names has more elements, get the next element, and for this particular balance dot get string, it will display the value of that particular person. John Doe, if there is a key John Doe, it will display 3434.34. Okay. Then balance dot get John Doe, put John Doe plus balance plus 1000, and his new balance is displayed over here. So what is new thing here is hash table. So same example we are implementing using the hash table. That is the new thing. Everything else is same. Okay. So just go through this. Okay. Next is hash table demo 2. Package hash table demo 2 is created in public static void main. Same thing we are implementing over here. Okay, show all balances, get set view of key using the set view, balance dot get set key set, it will give you the set, and using the iterator interface we are iterating. While iterator has next, get the next element and displaying the element plus colon plus balance dot get keys value. Okay, and deposit 1000 into John Doe's account. Balance is equal to balance dot get John Doe, and put John Doe balance plus 1000 currency, and displaying John Doe's new balance. Okay, nothing special in that, only iterator interface is used. Hash table is there, and whatever all is same, only difference is set view is get, and using iterator interface we are iterating that set view. Okay, only iteration type is different. Next project is, you can, if you need, you can go through this again. Hash table iterator set is imported. Okay, project is property demo. I will close this one. Property demo. package property demo is created. Then capitals are created. Capitals object is created of properties. Then this is the key, this is the value, this is country, and this is its capital. Then get set view of the keys using state. Then all of the state, this is the state and this is the capital, sorry. Then for particular object name states, the capital of name is capitals dot get property, and it is casted to a string. Okay, because we are iterating to an object, not a string. So explicit cast is needed over here. Look for state not in the list. We will specify the default. Capitals dot get property Florida not found. Okay, the capital of Florida is not found. Because Florida is not present in this capital property list. Okay, so this is the one way we have seen in theory part. If the capital is not present, state is not present in the list, we will specify the default like this. Okay, get property Florida not found. This is the one way. Now I will run this. Those who have completely understood the theory part will find it very easier. Okay, completely understand this all programs. And those who have not understood it, please go back and again try to understand it, learn it. Those are very simple examples. Okay, so now when Florida is not there, state is spread, capital of Florida is not found. This is the one way. Go through this project. State and their country, state and their capitals. Set view of the keys are get. For each type for loop, for object name, states capital of this particular state is this. Capitals dot get property name, and it is casted to string. Okay, so now we will see the second way. If the property, when the state is not in the list, what will be the output? Okay, close project. Then property demo default. So default value we will explicitly specify at the default as the default list over here. For Florida, it is a Tallahassee, and Wisconsin, it is Madison. Okay, so for default list we have put this, and this is the main list, and in the bracket of the properties, main properties, we have specified the default list. Okay, so whenever default list is over there, while searching, it will first find out in the main list, and if any state is not present in main list, it will go to the default list, and in default list it will try to find the names. If those states are over here, they will display these names, these capitals. Okay, all other things are same. This is the set view. This is the for style for loop to display the capital of particular state, and string, no need to pass here, not found, because we have already passed the default list. Okay, so now Florida will be found in default list, and it will display its capital like Tallahassee. Now I will run this one. The capital of Florida is Tallahassee. This is the second way. So there are two ways when property is found. When state is not found in the main properties, it will give you the default value, and second way, we will give the separate default list. It will first find out it main list, and if it is not present in main list, it will find for the second list, that is default list. And that is the main advantage of property. Okay, if no value is present, it will give the default value. So two packages you need to import both with this project, your java.util.property and java.util.set. Okay, this is the default list. It is created same way as the properties are created. Then main property list is created and default list is passed over here. Then set view of key is created, saved in states object. This is the for style for loop. This is the new line, and capitals.get property Florida, and now it will be found in the default list. Okay, so now we will move to the last program of your collection framework. So this program will end up our collection framework completely. That program name is phone book or phone book demo. This is the dat file created. Before directly displaying the dat file, okay, we will run this. You can find out the dat file viewer, so that it will open it and you will understand it, how the entries are placed over there, like person name and its value. Okay, okay. Phone book we will see one by one. We will close this project property demo default list. Second last project of collection framework, phone book, the package phone book is the phone book Java. Okay, so here these things are important: to read file, to write file, exceptions, output stream, input stream, and so on. Write down this, you have to all import. Next, properties object is created. Then buffer reader new input string reader system.in, so that user will enter the person name and his phone number. Then string name number is created. File input stream null, boolean change false. Try to open the file. Okay, if not found, it will throw the exception, ignore missing file. Then phone book is already existing. Load existing phone numbers. If this is not null, it will load. So what we have to try to understand here is load method. Okay, then close and error loading file. Then new name, to add to it, you will enter new names and their phone numbers unless and until you enter quit. Then number will be also read, and put method to put the name and number. And for output stream, store method is available. So two methods are available for properties. One is load and another is store. Okay. So now we will run this and we will try to understand. Name is my name. Number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And hello. Okay, so I put here name to find. I try to find hello over here. We will display the name. Display the number. Its number is same as this 7890675645. So it is successfully storing the values into phonebook.dat. Okay, again I try to find my name. its number is, and enter name to find. When no name is there, I entered 2, 3, 4, 5, 6, 7. So this is actually working properly. Okay. So this ends up our collection framework. If you want, you can go through this project and try to open this phonebook.dat. This dat file will be opened by different ways at your side, and try to read it so that you can understand it. Okay. Only thing it is you have to try to remember is load and store methods are available in properties class, so that you can uh, load the file and store to the file. That is reading from a file and storing to the or writing to a file. Okay. So go through this project one by one. Okay. So this way we have finished with the collection framework completely. Okay. So from the next session, we will start with our brand new chapter, that is utility classes. More utility classes in detail, their functions, their methods, how they are used, how they are implemented, and what is their actual use in our real world Java applications. Okay. So meet you in the next session with brand new topic, brand new chapter. Till then, you can enjoy Java, enjoy collection framework, and all the chapters you understood previously. Practice them, learn them, and first of all, enjoy them. Okay. So meet you in the next session. Thank you so much.